Hi everyone, these next few lecture videos will be covering section 10.4, which is on hypothesis tests for a population standard deviation. And before getting into this, I want to emphasize that section 10.4 will not be on test 3. This section will be on quiz number 5, and it will be on the final exam, but don't worry about this section for test 3, which is this week. So in the chapter 10 slides, there are background notes and there are some pretty good examples, and I would encourage you to take a look at those. For this lecture video, we'll use the lecture notes for section 10.4, and we'll start with a background on these kinds of hypothesis tests. So one way to conduct a hypothesis test for a population standard deviation is to use a probability distribution called a chi-square, and this is the symbol for that, a chi-square distribution. A chi-square distribution can be used for this kind of hypothesis test as long as 1, the sample is a random sample, and 2, the population of the data is normally distributed. Unlike a normal distribution and the t-distribution, the chi-square distribution is not symmetrical. It tends to be skewed right. All chi-squared values are non-negative. They range from 0 to infinity. The shape of the chi-square distribution depends on its degree of freedom, which is equal to n-1. As its degree of freedom increases, the chi-square distribution curve becomes more symmetrical. The chi-squared values are defined as being the ratio between the sample variance, which is sample standard deviation squared, and the population variance, which is the population standard deviation squared. Here's a picture of what these chi-square distributions look like. So they're usually skewed right. Here's a really exaggerated chi-square distribution. As the degree of freedom increases, the chi-squared curve becomes more symmetrical, and it looks more and more like a bell-shaped or maybe a T distribution. So all of these hypothesis tests in section 10.4 will meet the conditions required for using a chi-square distribution, and for this reason, you'll be using this distribution quite a bit in 10.4. So I also want to make a note about standard deviation, because this whole section is about testing hypotheses for standard deviations. Recall that a standard deviation measures the dispersion or the spread of data values. A large standard deviation indicates that data values are dispersed far from the mean and therefore are less consistent. A small standard deviation, on the other hand, indicates that data values are clustered close to the mean and therefore are more consistent. So this would signify a very large standard deviation, and the curve is showing that the data is very much spread out. And this would signify a small standard deviation, and here most of the data is around the mean. It's very close to being near the center. Businesses often strive to achieve a lower standard deviation or a lower variability for their product in order to achieve a more consistent product for the customer.